Hello, everybody. Today is Friday. Whoop, whoop. We have made it through our first week of digital learning. I hope none of y'all are really tired of looking at a computer screen because we have this for another week or two. Okay? But we're going to make it. We're pushing through. So, for our agenda today, for our lovely, lovely Friday, you should have watched the agenda video. Let's see what assignments you have for the day. You have no warm-up today. Happy Friday. You need to watch this reflections video, and then you have a drag and drop activity on Google Classroom. I looked at doing a My Math Lab assignment, and the problems they had on there weren't that effective in analyzing all this, so I figured we could mix it up and do a drag and drop activity. And because it is Friday, all of this is going to be due by Sunday at midnight. So you have 2 days. So you either work on this today or you could work on this over the weekend. As always, email me if you have any questions. A couple of y'all have emailed me about questions over the content, which is awesome. And sometimes, explaining something verbally versus typing it out in an email, that can be a challenge. So if ever I do send back an explanation and it does not make sense and it's not clicking, we could always schedule a Zoom conference, okay? And you and I could talk about the material, okay? But you just got to reach out to me and let me know. So today's topic, we're going to be diving into another type of rigid transformation, which would be reflection. Kind of like your reflection in the mirror. We're going to talk about the reflection of our pre-image across a line of symmetry to where we see its duplicate across that line of symmetry, except it's flipped. Funny story that reminds me of this is when I was little, was it the Cubs? I think it was the Bears. Well, it was the Bears. It was the Bears because it was Super Bowl. And I was staring into a mirror and I was like, woohoo, I'm just going to be a fake fan. Okay? Because why not? And so I took eyeliner and I wrote out the team name on my face. However, I wrote it while looking into a mirror. So obviously, when you looked at my face not in the mirror, the words were backwards. Well, the same kind of happens with reflections, okay? As it reflects across that line of symmetry, it flips it so it's a different orientation. The nice thing about a reflection is because it flips, all the points are the same distance from the line of reflection, or they're known as equidistance. We talked about reflection as being a rigid motion, and today, while we're looking at reflections, we're going to be looking at reflections across various different lines of reflection or lines of symmetry. You'll see that terminology mixed in between both of them. We'll analyze a pre-image in an image being flipped across a x-axis, a y-axis, a vertical, horizontal line, and diagonal lines. So that's bringing a little bit of algebra back. Okay, so as I'm going through the problems, okay, you're going to get tons of practice doing reflection. So if you're going through and it's clicking for you and you're getting it and you're ready to go start on some practice problems, that's fine by me. I understand that some of this material can get redundant. However, just be careful. I might add a tip later on in the video that you might miss because you're fast forwarding and clicking through. So that's your own prerogative. All right, let's look at some examples. Example 1. This is an example on the most basic form of reflecting a point across the line. So directions. If point P 3, 4 is reflected across the line y equals 1, what is the coordinate of its reflection? Okay, this is a great time for a little bit of review. So to note certain lines, if I have y equals something, whatever variable is right here, that's indicating what axis it's cutting across and where at. So here, y equals 1 tells me I'm crossing the y-axis at 1, which as you can see noted here. If this was x equals 1, my line would cross over the x-axis at 1, okay? What is the coordinates of its reflection, of its reflection image? So whenever you have a problem like this, Your first step is to identify where is my line of symmetry. Well, it's at y equals 1. Then it's your job to count these spaces between your line of symmetry and your point. So here I move up 1, 2, 3. So that means I'm going to move the opposite direction from my line of symmetry 3 spaces. 1, 2, 3. So my new point, okay, of P prime will be, let's see, it's 3, negative 2. That's my final answer. So really your job whenever approaching these is identify line of sim and 2, count distance, okay? Because that indicates how far to move across. All right, let's look at example 2. Here, I am reflecting across the x-axis. Okay, so before we looked at reflecting a point, now we're looking at reflecting our pre-image across the x-axis. The same program is going to work here. I identify where my line of symmetry is. I count the distance between those 2 points, and then I reflect. So here, my A, how far is it from my line of symmetry? It's 2 spaces. So 1, 2 gives me A prime. All right, B, so I go up 1, 2, 3, 4, 5, 6, 7. I come back to my line of symmetry. 1, 2, 3, 4, 5, 6, 7. There's my B prime. And then C is 1. Those are my favorite. 1. And count. Oh, connect your dots. There we go. And as you graph these, you can check. I'll be honest, when I was making this slides, there was one problem later on that I was practicing doing the reflection and I kept messing it up. I could not get it. Okay. How did I know that? Well, when I redrew my shape across the reflection, I was like, oh, that looks wonky. So you'll know and you'll be able to see if you mess up your reflection. So A prime is now going to be -4, -2. B prime is going to be 4, -7. Oh, I forgot my B prime. And C prime is going to be 5, -1. Now look at that relationship. Because I'm reflecting across the x-axis, let me change colors. Woo. Okay, my x's stay the same. And my y's just flip the sign. So as we're going through doing these problems, you'll analyze and you'll see these relationships. So if we were to predict for the next problem we're going to do, which is flipping across the y-axis, what can I predict? Well, I can predict that my x's will flip the sign and my y's will stay the same. So without counting spaces, you could also make some predictions, depending on where your line of symmetry is at. All right, let's do PQRS. My line of symmetry is my y-axis. Okay, so I'm going to go P prime, Q prime, R prime, S prime. I'm going to count my distance from my line of symmetry. So for Q, Q has 2. So 1, 2 gives me Q prime. R is 8. So R is going to be 8. And for P is 1. S is 7. So as you go through and practice these, you'll be able to do these a lot quicker. All right, check my shape. Does that look like it's reflected? Yes. How did I do that so quickly? Well, I knew that my y value was not going to change. The only thing that was going to change is my sign of my x. So my p is going to be negative 1, comma 2. My q is going to be negative 2, comma 5. R prime is going to be negative 8, comma 3. And my s value is going to be negative 7, comma 0. All right. And there we have it, folks. Here's our prime coordinates. If you have any questions while going throughout this, please, please, please let me know. Flipping across the x and y axis isn't too challenging. Now, I do want to make a note right here real quick. I'm currently babysitting my little sister. So if you hear the door swing open and interrupt the video, that's what it is. Okay? It's not the impending apocalypse where I have a zombie in my house. Okay? All right. Example 4. Now we're going to look at reflecting across a line of symmetry that's not on your axis. So it's not as simple as looking at my coordinates and keeping one the same and flipping my line. However, the most basic way to check this is to just count your spaces from your line of symmetry. All right, so I'm going to start with C. C is 1, 2, 3, 4, 5, 6. All right, moving up. Oh, I might go off my graph. 1, 2, 3, 4, 5, 6. Woohoo! C prime. D is 1, 2. 1, 2. F is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That don't look right. Yeah, that is right. F prime. And E prime is 1, 1. Connect my dots. Okay. And there we have it. Now I just need to write my coordinates. Oh, hold on, go back. C prime, D prime, E prime, and F prime. If you want practice graphing these, please go ahead and use GeoGebra. Okay, I do want to know how that is working out for you because I've played around with it a little bit. If it's effective, please let me know. If it's not effective, please let me know. Or if you found another tool that's amazing, please let me know. Okay, communication is key. Now I just need to identify my coordinates. Well, I am flipping across a horizontal line that's parallel to my x-axis. So what can I say about my x values? Those are going to stay the same. All my x values stay the same. The only thing that changes is going to be my y value. So C on my y value, it is going to be 8. For D prime, that will be 4. E is going to be 3. And F prime is going to be 7. Okay. So my y value is not so easy to predict. However, if you notice, if you compared your y values between each coordinate, they're all equidistant from each other because they've moved and flipped across the same distance. Okay? All right. Example 5. Now we're going to be looking at reflecting across a vertical line. So we've done a horizontal line. I want you to pause the video here, try it yourself, and then start the video back up. Okay? So for J prime, I am 1, 2, 3 spaces. 1, 2, 3. L, I am 1. Oh, let me, J prime. Okay. L, I am 1. L prime. And K, I am 2. And there we have it, flipped across. Now I just have to write my coordinates while I'm reflecting across a vertical line so I know my y values are not going to change. So -1, 3, -2. Now for my j values, it's going to be 7. K prime is going to be 6. And L prime is going to be 5. All right. Now, These are our other two forms of reflecting. Okay, this is reflecting across the equation or the line of y equals x. Well, if we remember back to algebra, y equals x expanded is written in y equals mx plus b form, where m is my slope and b is my y-intercept. Well, if I have the line y equals x, that means I have this basic equation right here. So y equals 1 over 1, or 1, my slope is 1, meaning I go up 1 over 1, up 1 over 1, down 1 over 1. And then my intercept is at 0. So I've already drawn my y equals x line. And I have my shape of GHIJ drawn on my graph. And I want to reflect it across the y equals x axis. Now, in this problem, it's not so easy to count spaces. However, what I do is I either pick, I'm going to count vertically or I'm going to count horizontally and then copy that same method here. So for example, if I have G prime, okay, to the line, I have one space. Well, if I'm going to count my space again, I am not going to go this direction. I'm going to move this direction to give me my G prime. If I wanted to go the other direction, if I want to go horizontally, I could go horizontally, then vertically. So for example, for J, I have 1, 2, 3, 4. Now I'm going to go vertically, 1, 2, 3, 4. Okay, and by graphing those 2 points, I can kind of already see that reflection. There's my segment. Okay, so now it's time to just graph I and H. So I is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And if I had to predict, my H would be here. But let me just double check. 1, 2, 3, 4, 5, 6. Oh, wait. I messed something up. 1, 2, 3, 4, 5, 6. Let me count my J again. Or no, my I. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where my point should be. There we go. Whoop. So I noticed I made an error because when I went and graphed, whoa. Holy cow. Okay. When I went and graphed my other point, I noticed that it was off. Okay. So when you make a mistake, the nice thing about reflecting is you'll be able to identify where that mistake is. So when I graph this up, I got H prime, and I have I prime. All right, let's identify those coordinates and see if there's a relationship between them. J is now -2, 2. I is -2, 7. H is 1, 7. And G is 1, 2. Well, look at that, folks. Okay, comparing my pre-image to my image, my X and Y value swapped. All right, so if you didn't even want to graph it and you wanted to indicate, okay, what's my values going to be, we could predict if we were flipping across a Y equals X line, I could say that my X and Y value switched. Okay, let's look at the last type of reflection. And this is going to be flipping across a Y equals -X line, where my slope is -1. My line is flipped in the opposite direction. Okay. Let's graph first, then analyze our coordinates. Okay, if you want to pause, try it yourself, go ahead. Okay, so A is 1, 2, 1, 2. B is, let's see, that's up 6. So I'm going to go over 6. Did I count? Let's see. 1, 2, 3, 4, 5, 6. 1, 2. Yep. Okay, my D is going to be 1, 2, 3, 4. 1, 2, 3, 4. So this is my A prime. B prime, D prime, C prime. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Winner, winner, chicken dinner. There we go. And if you tilt your head, okay, you'll see that that is reflected across the y equals negative x line. Let's analyze our coordinates and see if there's a relationship present. So for A, my A is going to be -3, 1. B is -6, 0. C is -5, 3. And D is -2, -2. So here, our relationship, if we flip across a y equals negative x sign, are x and y flip, and my sign flips for both. All right, so there's some kind of tricks to predict what your coordinates would be without graphing. All right, 2 more examples. We can do this. Now, let's say it does not tell you your line of reflection. However, it does give you your pre-image and image. So you are about to predict where your line of reflection is. Well, it's analyzing the distance between your 2 coordinates and seeing where that middle ground is. So typically it's easiest to find your coordinates that are closest together, which would be r and r prime. And I look, well, they're 2 units across, so 2 divided by 1 would give me 1. So if I were to count 1 unit, my line of reflection is going to split those images in half. Now I just have to write an equation for that line of reflection. Well, it's either going to be your axis. So here I do not have my axis. So if it was crossing over axis, I could write just x-axis or y-axis. But that's not the case here. Here, it's crossing an axis at a number. Well, what axis did it cross? It crossed the x-axis. So my equation is going to be x equals, and whatever value it crosses over at. So it crosses over at -3. So that's my equation. X equals -3. That's my line of reflection. All right? Let's look at another example. Example 9. I look at the distance between 2 of my coordinates. Okay, these are my 2 closest ones. So it's 1, 2, 3, 4. 4 divided by 2 gives me 2, which is going to be right in the middle, whoop, which is my axis. What axis is that? That is my y-axis. And that would be your answer. Not too shabby, right? Okay, that's all I have for you today. So you have watched your agenda video, you have finished your notes of reflection, and then you have a drag and drop activity on Google Classroom. All of this is due by Sunday at midnight. If you guys have any questions going through these problems, please, please, please let me know. All right, have a good day.